intense mining activity from your rigs will result in the generation of immense heat as your rigs consume electricity and while mining your bitcoins. The rigs itself has a small working temperature range, which ensures that the heat cannot be allowed to build up in the environment, and that the heat must be extracted in order to ensure optimal operation. Failure to do this correctly could lead to the rigs crashing, and in some extreme cases, there might be permanent damage to the rigs as well. This video is intended to include a basic understanding of cooling, the principles behind it, the different forms of cooling environments, construction architectures for your Bitcoin mining farm. This will allow you to better identify the specifications that you need for cooling at your mining facility. So, let's get started. The majority of the power used by your mining rigs is converted into heat, as I've already mentioned. It is necessary to eliminate this heat. Otherwise, the mining equipment temperature would increase to the point of failure. Now, the second law of thermodynamics in physics states that the heat moves from an object at a higher temperature to an object at a lower temperature. And we can utilize this law of thermodynamics in our favor. Through running a current of a cool air over the circuitry, heat can be eliminated from the mining rigs. Of course, the net effect of this cooling is that cool air is sucked into the rigs, and hot air from these very same rigs will be going to be exhausted out from it. The aim of the cooling environment for the mining farm is to transform the hot air that is exhausted from these rigs into cold air, which we can use a method called refrigeration to accomplish. Refrigeration makes it possible to successfully pump the heat energy that gets generated from the mining rigs to somewhere outside of that space, particularly where it is cooler than the temperature inside the space where these rigs are situated. The cooling equipment used in a Bitcoin mining farm varies from other types of systems used for residential or office spaces. These cooling equipment are designed to have much more precise environmental regulation and to regulate both the room's temperature and humidity. There are 5 major components that you will see in the mining facility's cooling system as shown in front of you right now. Let's go over these one by one. So let's start off with air handler or conditioner. Although there may be differences between air handler and air conditioner, in all cases, these are just cooling coils where air passes through and that the heat from this air gets extracted into the cooling fluid that are inside these coils. Next, it is the heat exchanger. Typically, the heat exchanger is mounted on the building roof or some other location outside of the facility itself. Depending on the type of cooling system that is deployed in your mining facility, numerous forms of heat exchanger can be used. Then there is the expansion valve. The expansion valve eliminates pressure from the liquid coolant to allow the evaporator to extend or shift its state from a liquid to a vapor. Although the liquid refrigerant exiting the expansion valve is cold, the high pressure liquid refrigerant entering the expansion valve will be hot. Inside the valve, the orifice does not expel heat, but rather it lowers the pressure. Then there is the pump, which is mostly for moving the cooling fluid throughout the system. Lastly, it is the compressor, which is used to cool the liquid with a condenser. The compressor takes the coolant that has been expanded into a gas, compresses it back into a liquid, and at the same time increasing its temperature, of which it is then sent to the condenser. Since in the beginning of this video I've just mentioned the concept of refrigeration, let us talk about the refrigeration cycle. A closed loop of evaporation, pressure change, condensation, and the flow control of the refrigerant fluid is what we call the refrigeration cycle, and it is shown in front of you right now. As you can see, It consists of 4 stages, namely the evaporation, compression, condensation, and expansion. So let us briefly go over each of these stages. Evaporation is the first phase, at which the heat is derived by the return of hot air from the space where your mining rigs are. The hot air from the space is then blown through the evaporation coil. The evaporation coil has cold liquid running into it, which, by extracting the heat from the airflow through the coil, turns this liquid into gas. The conversion to gas can happen at this relatively low temperature for a state change due to the pressure being maintained within. The second stage is the compression. The vaporized refrigerant gas, still relatively cold, is then pulled through a compressor that compresses the gas into a high-pressure liquid. The method of compressing the gas into a liquid allows the liquid to increase in temperature, resulting in a hot liquid that is then transported to the outside environment where the heat is extracted. The pumping the hot air into a condenser coil to extract the heat is what we have in the third step in the cycle, or what we call the condensation stage. Then we move on to the last stage of our cycle, which is the evaporation. So even that the condenser coil has cooled the refrigeration somewhat in the condensation stage by extracting the heat, as it exits the coil, it is still a relatively hot vapor, and too hot to directly cool the mining farm. The refrigerant is then piped through a system called an expansion valve. And the expansion valve helps significantly decrease the pressure of the liquid, which in turn lowers its temperature. The resulting lower pressure liquid then reaches the evaporation coil again, initiating the cooling cycle at the evaporation stage, and thus it goes on and on and on. Now that we have reviewed the refrigerant cycle, let us now look at the cooling architecture. There are a variety of different architecture or configurations that are available for mining facilities, and this mainly differs depending on the site of which you will be building your farm. However, it is important to note that the cooling architecture of the mining facility is not something that can substantially drive the site selection process, unless the site is going to be a world-class big mining facility, which the probability of that applies to your case would be pretty slim. It is important that you have a clear understanding of how your mining equipment is cooled by the various architecture. The cooling architecture differences rely on differences in how heat is shared between the facility's interior with the outside environment. In the most simple configuration, we will use 2 heat exchangers, where the first one removes the heat from the air and transfer to the refrigerant, and the second heat exchanger removes the heat from the refrigerant and transfer back to the space with the mining rigs while the heat is transferred to the outside air. The 3 most common architectures are the air-cooled, the water-cooled, and the glycol-cooled. In most crypto mining farms, you can see that the air-cooled architecture is mostly the standard architecture to use. In its most simplest form, the mining farm will only be using a computer room air conditioner comprising most of the components of the cooling cycle, which includes the compressor, evaporation coil, and the expansion valve, along with a condenser unit outside the building. It is necessary to remember that other components such as pumps, valves, and filters may be needed in the system. Another typical architecture of the cooling system puts an additional major component between the internal air cooling units and external heat exchangers that transfer the heat into the outside air around them. This component is referred to as a chiller. With this system, there would be a private cooling loop of chilled water that is cooled to a temperature of about 8 to 18 degrees Celsius that services the facility. The cooling loop would then transport the water to the chiller, where heat is drained from it, and from the chiller, the heat exchanger transfers the heat to a second refrigerant loop. In comparison to using an air conditioner in the air-cooled architecture, The cooling unit in this architecture is usually an air handler instead. They have the same general function, however. They do it quite differently. The cooled water in an air handler is moved through a coil, and to get the heat withdrawn, the cooled water is heated and then pumped back to the chiller. As in the case in what you see in front of you right now, the chiller is just a heat exchanger of the facility and external refrigerant loop where the main goal is to transform the heat to the air outside. The third common type is the glycol-cooled architecture. The glycol-cooled architecture differs from the air-cooled configuration by replacing the condensing coil with a heat exchanger that moves the heat into a secondary loop away from the cooling cycle that then goes to a dry cooler outside the building that transfers the heat to the ambient air. Glycol is used because it can retain more heat than the same volume of water or air. This combination decreases the function size and the pipe size necessary for the heat to be transferred out of the facility. While the key equipment used to provide cooling within a crypto mining facility, you quite possibly have no control. Especially if you are co-leasing or sharing the facility with some other businesses, you can still determine how the air is being distributed within your facility space. In any air delivery design, there would be a variety of factors that you need to be considered. The mixing of the hot and cold air streams would be the toughest consideration in air distribution design. Nevertheless, containment and the location of the cooling units will be crucial to your air delivery architecture performance. Let us now go over the common mechanisms in air distribution. There are 5 most common mechanisms for air distribution, and they are the flooded air supply, contained air supply, contained return, targeted return, and a targeted air supply. Let us start with the flooded air supply. A flooded air supply system is basically one where the flow of hot and cold air inside the facility is not controlled. There is considerable mixing of hot and cold air, leading to a cooling environment that is very inefficient. Now, for the contained air supply, both the cold and hot air are enclosed to eliminate mixing between the air of different temperatures. One way to do this is to feed the cold air through the ductwork or under the floor, if it is a raised floor system where the mining rigs are in rows of enclosed environment. The hot air is then expelled to the room environment. The third type, contained return, is the opposite of contained air supply, where the hot air is instead exhausted to the ductwork or the bottom flooring, and the cold air is flooded into the equipment room. As for the last two, targeted supply and target return architecture, you will still utilize either the overhead ductwork or the raised floor to direct either the cold or hot air. However, in this case, it would not be directed into or out of an enclosed environment. The answer of which architecture to choose is relatively straightforward. That is, where the more control you put over the air and movement, the higher the solution's cost will be. So you will always need to balance what is more important, whether or not the flow of air or the cost that you will pay. If you're thinking about this for a long-term approach for a large-scale mining farm, I would recommend at least the target supply architecture, just so it has more control and efficient air circulating environment. For temperature and humidity, you need to first consider the temperature and humidity limitations that your site imposes in order to resolve the whole temperature and humidity problems. You also need to determine the temperature and humidity levels that you need to operate your mining rigs. Therefore, the operating limits of your rigs in terms of temperature and humidity needs to be guaranteed that it will not be reached when operating in your facility. I would recommend that at the intake vents of your rigs, you should install sensors measuring the supply air temperature. You should also set up multiple alerts that will alert you on your mobile device or something as to whether the temperature or humidity raises or decreases to a point where the activity of the mining rigs are at risk. Furthermore, the environment that the rigs are in will start warming up in the event of a cooling malfunction, leading to a steady increase in intake temperature. Before you have hit the limits of the mining rigs, you would want the starting point of the temperature rise to be low enough to allow you some time to get the cooling back online before any real damages can be done to your mining rigs. It is obviously one of the most critical factors in a Bitcoin mining farm to keep the mining rigs cooled. That said, there's a difference between the need for power and the need for the integrity of the cooling system. A failure of the cooling environment for a few minutes is not a disastrous occurrence, but power should not be lost to the rigs for even a fraction of a second. The explanation for this is that in a mining farm facility, there is a comparatively large thermal mass that creates a time buffer until the temperature increases to the extent that the mining rigs are going to be at risk. As such, cooling equipment does not necessarily need to be connected to the UPS, but it does need to be tied to the backup generation, if there is one. As for redundancy of the equipment, I would recommend an N+1 redundancy model. However, if you do not require a continual operation, this really does not matter, as when it fails and it alerts you. You should have enough time to shut down these rigs before the heat buildup can do any permanent damage to your equipment. I will go over redundancy further into this course. Lastly, I would like to go over some bits and pieces of things that you can do to improve the cooling architecture. And they are the blanking plates, the brush plates, extra wide cabinets, and routing of cables. Blanking plates should be installed in any unused positions in racks and enclosures of which the rigs are mounted, because this can actually greatly help the airflow control. These can be easily installed and they are not expensive, so be sure to consider installing blanking plates on any unused positions. Now, if you need to reroute cables from the front of the to the back of the cabinets and vice versa, consider to install brush plates for the reroute of these cables. Now, these are similar to blanking plates, where it actually helps the airflow by blocking the air from going from the front to the back of the cabinet uncontrolled. However, in the case, it has brushes instead, so that you can have cables to go in and out of these plates, but you got brushes to prevent or limit the airflow in between. The last two, the extra wide cabinets and the route of cables or rerouting of cables, is basically the same thing, in which the main objective is to not impede airflow and to maximize the architecture, the cooling air architecture that you will be using. Besides your mining rigs, the second most important asset that you will have in your mining facility are your cables. Cables in your facility affects a lot of how you design your mining facility, and cables might be the asset that, if not spec'd or maintained appropriately, would lead to the most failures within your mining farm. In this video, I am going to talk about cabling within your mining facility. The very first thing to do is to consider which standard philosophy you want to stick to in the design or procurement of a cabling scheme. There are three paths that you can follow, and they are: first, defining the cable grade that you need and just have the installer sort it out. The second path is to rely on the cable manufacturer to know what is best for your needs. And finally, the third path is to refer to one or combination of industry standards. Now, leaving the cable specs and the system design entirely in the hands of an installer is a very dangerous choice and can only be contemplated by those aiming for just getting the job done at the lowest price possible. However, do not ignore the continuing cost of ownership, as you may pay a huge price down the road in cable failures if they are not spec appropriately. Now, a lot of companies, including utility companies, often rely on the cable big brands to have them tell you what cables to use and what cabling system should be in place. Now, the reputable manufacturing companies do have experts where they know the industry standards inside and out, but their willingness to help you will depend on whether or not you are considered a big client or if there will be any continuing businesses with them. Now, with Bitcoin mining facilities, it will be hard for them to be enthusiastic in lending their expertise to you. Also, it is more common than not that cable companies go into a lot of mergers and acquisitions. So often than not, you will not stick with a particular cable manufacturer when you need to do cable replacement. Not to also mention that although they have a general industry knowledge, they don't have specific knowledge of what you need in your particular mining facility. So it is best to have knowledge on your own cable design. In our mining facilities, essentially there are two types of cables that you need to be aware of. One being the power cabling and the other one being the telecommunication cabling for communication on your rigs, in which we refer these as data cables. As such, you will need to refer to a set of standards for both power cables and telecommunication or data cables for your particular region. Now, if you are in the United States, for telecommunication or data cables, you can refer to a standard called TIA 568, which focuses on telecommunication cables in commercial buildings. As for the electrical portion, and I'm referring to United States again, you can refer to the NFPA 70, or what we also know as the National Electrical Code. Please don't refer to these standards if you are not building your mining facility or your mining farm in the United States, as the requirements are different from region to region. Nevertheless, you will need to refer to the standards in your particular region for commercial building cables for both electrical and telecommunications for your facility build. Let us start with the concept of structured cabling for telecommunication cables. Structured cabling is a cable infrastructure for voice and data communication applications. Structured cabling provides one point of origin for the whole system. Other units are connected to the system when needed. This helps you to have a single hub where any improvements to the system and repairs can take place. If the telecommunication infrastructure in your mining farm is badly built or poorly constructed, it can lead to downtime and unnecessary cost for maintenance. Intermittent failures are some of the most frequent problems with bad infrastructure design and implementation. The telecommunication cable system contains essentially two major building blocks, that is, the cable itself and the connecting hardware. For the cables, the most important parameter is its characteristic impedance, and these are split into categories as stated in the ISO standards. Without going into any deeper, you only need to know that the only ones that you need is category 6 or 7 cables, with the most prominent being 100 watt characteristic impedance of these categories. Now, if you want to learn more about this, you should get a copy of ISO 11801 for more information. Now, most of your cables of your facility will be residing indoors, but there will be cables residing outdoors as well, such as from the telecommunication demarcation point, which is usually off from a pedestal, to your building. These cables will need further requirements as they need to be outdoor rated as well. On top of the requirements of indoor cables, you will also need the cable to be water resistant, and in the case where the cable will be exposed to sunlight, it needs to be UV resistant as well. If it is buried underground without ducts to protect it, then you will need to specify outdoor cables with armoring, such as external galvanized steel wire and or corrugated steel tape. The other major component is the connecting hardware, where the most common ones are either 8-pin modular connector plugs and sockets, and the other type is the insulation displacement connectors, also known as the IDCs. Cables in the end will be terminated in what we call a patch panel or patch bay, which is situated on the racks or cabinets of where your mining rigs are for your rigs to connect to. Some more expensive patch panels has an added level of intelligence by displaying connectivity information as well. In the end, the connections will get rerouted into the router and then through the modem to be connected to the internet. As briefly mentioned in the other videos, how power cabling works really depends on your region's electric code. So what I'm going to talk about is going to be very generic. For example, in the United States, we will refer to NFPA 70 and NEC Article 300 and 310 for wiring methods of the mining farm. As general methods, we usually have two choices, the raceway conductor method and the busway method. The raceway conductor method utilizes conduits or tubing with insulated phase, neutral, and ground conductor, where each raceway and conductor is field fabricated. The advantage of using raceways is that changes can be made comparatively easily, but it is limited to the number of bends before you need a junction or a pull box. The second method is called the busway method, which is a metal enclosed raceway with factory mounted bus bars. The advantages for using this method includes being a bit more compact and less use of space, but it is also more costly and more susceptible to water leaks as well as potentially high short circuit current. For both the data and electrical cables, PVC or polyvinyl chloride and PE, or so-called the polyethylene, are the most common insulating jacket being used. These jackets are combustible and have a probability for propagation of fire, and this is more prominent when the cables are bundled together. Now, fire protection of the cables in your mining farm is really not a must-have, but it's good to keep it in the back of your mind when you are choosing cables for your mining facility. With both types of cables, there are various fire retardant coatings available depending by the manufacturer that prevents fire propagation along the cable. I would also recommend to look at low flammability, zero halogen material options. The reason for this is that the halogens in the cable, although a flame retardant itself, releases toxic fumes when combusted, which not only cause harm to cable, but it will also have damaging effect on circuit boards, which also means that it may damage other equipment that may not be directly affected by the fire itself. And when I mean by other equipment, I mean your mining rigs. If you are interested in looking at this topic further, I would advise you in looking at IEC 6332, which lists out the test on cables under fire conditions. One area within your facility that you need to pay extra attention to is the plenum space, which is the space that is used for air circulation system. This area carries airflow between the interior of the facility and the outside environment, which makes fire easily spread in this area. This space is usually located between the structural and suspended ceiling, as well as under the raised floor. Now, if there's any place where I would recommend, if you want to have extra fire protected cables, you should install it in these areas, as these are what we would consider as high risk areas of catching fire and spreading fire. As a general rule, there needs to have a defined protected route that will protect cables from the external environment. You should not have cable installers to randomly route the cables by only giving them the need of installing cables from point A to point B. Now, some of the consideration that we need to look at include the following as shown in front of you. And we got 4, which is bends, bundle size, intersecting cables, and the separation of cables. Now, with bends, when designing the pathway or routes for your cables, you need to make sure that any of the bends are not less than the bending radius set by the manufacturer. And if the bends are too tight, the cable may become damaged. As for the bundle size, there is no limit as to how many cables can you bundle at the same time, but do keep in mind that the bigger the cable bundle, the harder it is to manage and maneuver. So put that in the back of your mind when imagining you're pulling cables. The higher your bundles, the number of cables that you're in your bundle, the harder it is to be pulled. Now, as for intersecting cables, in the case that if you need to have your power cables intersecting with the data cables, you need to make sure that it is done at 90 degrees. And this is because we want to minimize interference caused by these two cables. As for separation of cables, if possible, we should separate the parallel runs of power cables and data cables by 20 centimeters. Now, it is not a must. This is just a recommendation. If you are interested in further readings on these, there are numerous standards that you can reference it from. I recommend in starting with the ISO 18010, which is titled Information Technology, Pathways and Spaces for Customer Premises Cabling, as well as IEC 60364, which is titled The Electrical Installations for Buildings, for more details. Lastly, let us talk about grounding. For safety reasons, all exposed conducting surfaces must be attached to an earth point. This is to guarantee that any accidental completion of the circuit due to touching of the conducting surface would create a big enough fault current that a fuse or a circuit breaker would blow. If these exposed circuits or surfaces are not attached to an earth point, or in other words, left floating, the live voltage would be retained until someone or something makes contact with it, at which point they would form the conductive path to earth. The goal of having electrical bonding system in the mining facility are due to 2 main reasons. And the first one being to have protection against electrical hazards, like the one that I mentioned before, being forming a path or conductive path to earth, and 2 being using it as a signal reference for some equipment. Now, point 1 and 2 are actually referring to 2 different types of earth connections. Now, of course, the first point refers to protective earth, which is to prevent exposed conductive surfaces from carrying fault currents. But the second point actually refers to what we call a functioning earth, which is to provide a 0-volt reference point for some equipment to function appropriately. Equipotential bonding is a mechanism which is used to maintain a series of electrical equipment to achieve a relatively similar electric potential. This means that we will connect anything metallic that isn't part of a current carrying circuit to everything else before being connected to earth. The main idea behind this is that current flows in a voltage or potential difference. So if there is no potential difference, or what we call equipotential, no current would flow in between these. Bonding should not only be just connecting the equipment, but also to service pipes, ducting, heating, and the conditioning or air conditioning system. You connect all of these components through something called a bonding conductor, which the size of it will depend on the anticipated fault current your facility might have. If you're concerned with electrical safety, meaning that during an electrical fault, it might cause potential injuries while you were tinkering with the equipment, which it is just so you know, very unlikely given the amount of current and voltage level that it will be at your site. But nevertheless, you can still use electrically rated PPE such as electrically rated boots and gloves to touch the equipment if you have a concern of electrical fault and electrical safety. The thing is, speccing, designing, and installing cables is a very complex process. I highly recommend you to not do this on your own and hire a certified licensed contractor to do this for you instead. The thing is, I have only touched the surface of this subject, and you will need years of schooling and apprenticeship to get this correct. Not only that, to acquire the relevant business and operation permit for your mining farm, depending on the region that you are in, will actually require inspectors to sign off on your site that it satisfies all requirements of the local electrical and building code. And any non-conformance may require you to redesign and rebuild of your facility before you can start mining your first coin. So you will not save any money by doing it all on your own. Unless, of course, you are an experienced person already in doing electrical and network connections for various buildings with complex IT infrastructure, then I would say go for it. But still, I think the best way is to go for a reputable contractor to do this work. And I'm not saying just for cabling. I'm also saying the other things that I have talked about, which is the power portion, the cooling portion, the construction portion of your site. As you have probably figured out already, the information that I have given you is actually more or less catered towards you hiring the contractor and to be effectively communicating, not to actually design and build it your own. So by watching the videos within this course, you should have enough information to express what you need for the infrastructure builds on your mining site. Now, if you need additional details or any other materials in order to communicate to your contractors or your builders effectively, then I would consider reading the materials that I recommended throughout this course for more information. But nonetheless, I am not here to teach you to build this from scratch by yourself. But what I'm here to do is to make you to be competent enough, to be confident enough to make sure that you have the tools that you need to communicate effectively to your contractors and your builders to build the state-of-the-art mining facility that you need for your mining operation. In this video, I would like to touch base on the security that is needed for your mining farm facility. First, let us talk about the surroundings. Now, I remember I've gone over this briefly in a previous video, especially look at the location and the building. It essentially all comes down to what your neighbors are and whether if there are any potential dangers due to the surroundings. Now, when you are considering the neighbors of our mining farms, of course, we do not want criminals as our neighbors, but my main point is to actually avoid tenants that might potentially be a hazard to your operation. For example, you should avoid establishing your operation in close proximity with a business that manufactures explosives or other things that might cause explosion or fire hazard. Also, you should not choose places where it may be a target of potential attacks, such as military contractors, pharmaceuticals, or financial services. Also, you should avoid places where there might be susceptible to vehicular impacts. There are many cases where the drivers were heavily impaired and lost control of the car, in which it will then crash and cause huge damage to facilities in general. I'm not saying that it will happen or it has a high probability of happening, but I mean, if possible, try to minimize the hazard as close to zero as possible. So to avoid this, make sure to avoid choosing locations that are close to high traffic roads. Remember, to avoid being in a situation of danger is the best type of security for your mining farm. Now, let us look at some of the security consideration for the building itself. And we got three huge consideration, which is protection, parking, and walls and opening. Now, with walls and openings, if you are co-leasing the building complex with other businesses, ideally, your space should not have walls that are facing a roadway or in a way that a vehicle can ram through the wall. Another most ideal case would be to have a space with no windows and kept the number of exits or entrances to a bare minimum. Again, this is to minimize any security risk by minimizing the contact points of which accidents can happen. Also, we should avoid to use any markings or any indication in the exterior building, as we don't need to tell the world that we have expensive mining rigs that are inside for thieves to grab and to build their own mining facility, for example. Now, for parking, we should avoid having parking spots that are against the building or to the walls of the facility. And again, this is to minimize the contact points of which accidents can happen. As for protection, in the case that you have walls and openings that are exposed and you can't really do anything about that, then you may need to add exterior protection such as fences, jersey, or concrete barriers and a gate for your area. You have a lot of expensive equipment in the mining farm. And not only that, these expensive equipment, and namely I'm referring to your mining rigs, are highly sought after as it allows someone to easily generate the hottest commodity in the world right now, which are Bitcoins and other types of cryptocurrency. As such, you will need 24/7 security personnel to monitor the site and keep it secure. The security personnel or team should take walks around the facility according to a prescribed timetable. The intention of this is to take note of something that could go wrong, such as a door wedged open, boxes or equipment in the aisle, or spotting suspicious people, etc., as well as making sure that these items are taken care of, and also they would notify you when such events happened. Deploying surveillance cameras inside and outside of the facility is a must, as it not only records the events that are happening, it also deters to a certain degree of theft and vandalism as well. Security cameras should be installed at locations that maximize visibility and should have redundancy so that if one camera is down, there should be another one at a different angle that can see what happened. When deploying security cameras, the two questions that you need to consider are, first of all, what does the security department do, both internally and externally, regarding the site surveillance feeds? And the second question being, how many cameras are there and where are they going to be placed? Surveillance is usually a reactive activity. Even the cameras on the video monitors are rarely actively watched. Everything is still going to be recorded so that when something disappears or a bad event occurs, there is going to be a record. Now, in order to solve a problem or a incident, these camera recording will going to be very valuable and useful. So in a sense, one of the most important thing that you need to consider also is you need to determine how long the video recordings should be kept. My recommendation would be usually 3 to 6 months would be fine. As you know, more than that, you probably are not going to revisit those for particular incidents. But whatever that you choose, as to the duration of which you keep the recordings, you should standardize this number. So you should actually use it as, put it in the policy of which you are going to maintain all of the feeds in that particular time duration. And there should be no negotiation on that. So everything should be kept at that particular duration. Now, lastly, for security, I want to touch base about security access. For security access, I would recommend card readers or the badge access system, where access is only given to a very specific group of individuals as well as the security personnel or team. There should also be logs as to the timestamp of each access and by whom. So with a badge access system or card readers, these are a lot of systems have already automated logging if you're utilizing these. Now, of course, if you're not owning a large-scale mining farm, you may only want the normal lock and key. But the level of security will be very low, and considering that you have expensive mining rigs in the facility, I believe it is worth your investment to get better security mechanism. Now, on the more extreme end, you can also consider the use of biometric scanning, which identifies you by your biometrics, such as fingerprints or retina scan. Now, of course, this is a much better method than the electronic locks, but the cost and complexity of implementation on these may be too much for mining farms in general. So, in a sense, I would still just recommend using just the card readers or the badge access system for your mining facility.